Hi friends, welcome back to Edupedia world. Today we will be discussing further on calorimetry, and the discussion will be focused on phases or different states of a material. We will understand what a phase is, what are the different phases a material can exist in, and how this phase change of phase from one form to another affect it. Finally, we will see some factors which affect the phase change and how those factors actually affect the phase change. You will learn a lot of new terminologies in today's lecture. So without delay, let's see what we have got in phase and phase change. Let us begin the lecture by discussing change of phase or state. So today we will be discussing about phases or states. What do I mean when I say phase or state? To understand this, we need to understand how can a material exist? In what forms does a material exist normally? Like, for example, take water. Water can exist either as ice or in the liquid form as water or in the gaseous form as vapors. So these three different forms in which water can exist are called the three states of water. Okay, so under normal circumstances, any material can have three states or three phases. What are those three states? The first is solid, then there can be liquid, and ultimately there is the gaseous state, gas. So what determines which state will be existing under a particular circumstance? That is determined by conditions of temperature and pressure. What is the temperature at that given moment, and what is under what pressure is the material? These two will combinedly decide what state will the material exist in. So the state is a function of temperature of the material and the pressure of the material, pressure under which the material is kept. Okay, so what we see is under normal circumstance, the three phases are solid, liquid and gas. We will not discuss the special cases like the case of plasma, which is ionized state existing at very high temperature. We will not go into details of those states. We will just focus on solid, liquid and gas. So as I discussed, an example would be solid is ice, liquid is water and gas is water vapor. So with this background, let us try to find out how can we interchange one state to another. As I have already mentioned that the state or the phase is a function of temperature and pressure. So what can we say about different phases? What we can say is that we can interchange phases by changing these conditions. Under normal circumstance, the pressure is being kept constant. So what is varied is the temperature. So we either heat the material and the temperature rises, or we cool the material and temperature falls. And as a result of that, the material will transform from one state to another state. Now let us see what the transformations are called. Okay, so solid is the state which exists at the lower end of the temperature. For colder material, solid is found. Then Second is liquid. If we rise the temperature sufficiently, we will get liquid from solid. And if we further rise the temperature sufficiently, we will get gas from liquid. Now the other way around, if we cool liquid sufficiently, we will get a solid, and if we cool gas sufficiently, we will get a liquid. So there are special names for these transformations. Let us see one by one. A solid getting converted into a liquid is called melting. This is melting. So basically a solid melts into a liquid. A liquid getting converted into a solid is called freezing. You must have heard that water freezes to ice. So that is what it is. Freezing. The liquid state water getting converted to the solid state ice. Now let us see the other side. Liquid to gas. Liquid to gas is called vaporization. Vaporization. And gas to liquid is called condensation. So water vapor condenses to water. S-A-T-I-O-N. This is SA. Okay. Now there can be scenarios where we can directly convert liquid to gas. That type of transformation is called as sublimation. So liquid converting to sublimation is liquid, rather solid converting to gas directly. So now we have a feel and we have a mental picture with names for the different transformation. Okay, so let us see them one by one. Melting. Melting is also known as fusion, and this basically happens when a solid changes to liquid. So melting or fusion is solid to liquid transformation. And a very important concept about transformations, about the change of phase, is that when the phase is changing, then the temperature during the phase transformation does not change. Very important. During phase transformation, the temperature does not change. So the whole process of melting takes place at a fixed temperature. But you will say that we are continuously supplying heat, right? We are heating it for the transformation to take place. And how come the temperature is not changing? In the previous lecture, we studied that when we supply heat, the kinetic energy increases. As a result, the average kinetic energy represented by temperature should increase. But what happens during phase transformation is that the heat energy that we are supplying is going into changing the state rather than changing the temperature. So this is a very important concept, that during phase transformation the temperature does not change. Okay, so when ice will be melting to water, the whole process will take place at exactly 0 degrees Celsius under standard 1 atm pressure. So how much soever heat you supply, until and unless the whole ice melts to water, there will be no change of temperature. Okay, and this constant temperature at which the transformations takes place has a special name. So for solid till liquid, it is called as the melting point, right? So basically it comes from here. So let me write it here. Solid to liquid is called melting point. And to do this, what are we doing? We are supplying heat, right? Now for liquid to solid, that is freezing, the term used for the temperature at which freezing takes place is called freezing point. So let me write it. Liquid to solid is called freezing point. And to freeze a material, heat is extracted from the material. So we are not supplying heat, but we are extracting heat away. Extracting heat. And this heat supplied to convert solid to liquid will be exactly equal to the heat extracted away to convert that liquid back to solid. So these two are interchangeable. If we supply a certain amount of heat to melt a solid, we'll have to take away that much amount of heat to freeze the solid, right? And as we have already said that any phase transformation takes place at a constant temperature. So solid to liquid supply heat, liquid to solid extract or reject heat. Now let us see what is the change in volume when melting takes place. Okay, during melting most of the material expands. So when a material is melting, when a material is changing phase from solid to liquid, most of them expand. The rare exception being water. Water is one of the few substance which contracts on melting. So this is another highlight. Water contracts on melting. Most other materials expand on melting. Now the fact that water contracts on melting, that is the volume of water is reducing when it is melting, has very practical implications to marine life, and we will see that in details in next lecture. But you need to know that this has very practical implications. Now what is the effect of pressure? What does pressure do? What does changing of pressure, how does it affect the melting point? So here too there will be two cases. A material like water which contracts on melting will have melting point reduced on increasing of pressure. If contract, I am writing as MP for melting point, reduces when pressure increases. If expand on melting, this contract and expand is during melting, then the melting point increases when pressure increases. So this is the relation between melting point and pressure. Therefore, water will, when you press water, if you provide, rather if you press ice, then what will happen is that its melting point will reduce. The melting point will go below 0 degrees Celsius when the pressure is increased on ice. But that is only for ice. Other materials which expand on melting, if you increase the pressure on them, then the melting point will increase. Now let us see what is the effect of impurities on melting point. This is the effect of pressure. Effect of impurities is that on adding impurity, the melting point of a material, irrespective of what material it is, the melting point reduces. So any material will have its melting point reduced when we add impurity to it. And there is a very practical application of this concept. In very cold countries where there is a lot of snowfall and the road might be blocked due to ice, what is done is that a mixture of salt is spread over the road. It's thrown on the ice. As a result, this impurity particles, that is the salt particles, reduces the melting point of ice and the ice melts away. So now the melting point might be, let's say, reduced to minus 15 degrees Celsius and the outside temperature is minus 10 degrees Celsius. So the addition of salt will melt away the ice which otherwise would have been intactly present, right? So this is a practical application, and now we know that impurities reduce the melting point. Now let me see the other aspect of it. We have seen this part, solid to liquid. Let us see liquid and gas relation. So liquid and gas relation, what is it called? Liquid to gas is vaporization, and what is the temperature called? The temperature is called boiling point. I will write down here itself. This is called boiling point. Okay, and gas to liquid is condensation, or it is also called as liquefaction. Liquefaction, liquefaction. So the boiling point is also a constant temperature at which the liquid changes to gas. So we keep on supplying heat to liquid, it keeps on rising in temperature, and then it reaches the boiling point. The liquid phase starts converting to gaseous state without rising temperature. The whole liquid converts to gas at the boiling point temperature itself, and then again when it's completely converted to gas, the temperature again starts rising. Okay, so this is the concept of vaporization, and for boiling or for vaporization we need to supply heat like for melting, and for condensation we have to extract heat. Heat is given away by the material, and that is similar to freezing, and these two heats are again equal. So if we have to apply 150 joule to convert the liquid into gas, we will have to extract away 150 joule to convert the gas back to liquid. Okay, now let us see what is the change in volume. For the solid to liquids, we have seen that volume mostly increases, but in rare cases like water it decreases. But in the case of vaporization, the volume always increases. That is to say that the gaseous state always have a larger volume than its equivalent liquid state. Okay, so in boiling in boiling, volume always increases. So this is the concept of volume change during boiling. Now let us see the effect of pressure on the boiling point. Since there is no partition like contraction or expansion, it always expands. So the boiling point also follows a single trend, which is the boiling point increases when the pressure is increased. So if you increase the pressure of something, then its boiling point will increase. This is exactly the concept that is used in pressure cookers. What we do in pressure cooker is that we seal it so that the pressure inside increases. As a result, the boiling point of water will increase, and that will help to cook relatively easier. On the contrary, on the opposite side, uh, if you go to hilly regions and at high heights, what happens? The air pressure drops. When the air pressure drops, the boiling point of water reduces, and as a result of the reduction in boiling point of water, cooking becomes a lot more difficult at hilly regions. So now we know the relation between boiling point and pressure. Let us see the relation between boiling point and impurities. So if impurities increase, if impurities is added, impurity increase means impurity is added to a liquid, then the boiling point of the liquid increases. So another way to cook fast is to add some common salt into the uh, material we are cooking that has water. As a result, the boiling point of water will increase and cooking will become easier. We are not going into the science of why boiling point increases on increasing impurity and why melting point reduces on increasing impurity, but there is, as a matter of fact, precise science behind it, but that is beyond the scope of our syllabus. I'm not going into details of that. So today's lecture we saw the different phases and what are the phase transformation called as, what are the temperatures at which the phase transformation takes place called as. We understood that the phase transformation takes place at a constant temperature, and we also saw how the phase transformation takes place, what is the effect of temperature on change of pressure on the volume change during transformation, and change of pressure on the temperature of transformation, change of pressure on what temperature the transformation will take place. Also how the impurities affect the boiling temperature, the boiling point and the melting point. So this has been a long theoretical lecture. In the next lecture I will discuss something called as latent heat and specific latent heat, and with that understanding we will solve certain numericals after that. So till the next lecture, have a great day. Goodbye.